In this video, we are discussing the asynchronous version of the field strength lab. In this lab, you will be measuring the strength of an audio field as a function of distance. If we think about how your ears work, you are just noticing the pressure change from a sound. And that is the intensity of this field being produced by that sound source. So we will be using sound intensity as our analogous field. Now this lab could be performed using any number of fields, such as an electric field, or a light intensity field, or a magnetic field. It just so happens that sound is one of the easier ones to measure accurately at home. For this lab, you will need a single sound source, like one speaker, that is going to be producing a constant clean tone, like a sustained note. There are many ways to get your computer or a device to do such things. You can look up tone generators and things for tuning instruments. There are lots of options. You also need to measure the intensity of that sound as a function of distance. Measuring the exact distance will be important. Ideally, you would use something like a tape measure or a ruler, but if you don't have that available, anything that you know exactly the right distance of and doing measurements off of that can work, but really something like a tape measure or a ruler or a meter stick would be ideal. The other value we need to measure is how loud the sound is. There are many apps available for your devices that can do this, sound level meters, things like that. The thing that we need to be careful about is that sound level and sound intensity have very different units. Sound level, decibel system, is a logarithmic scale, which was designed to mimic the way our ears work. For a concert to sound twice as loud to the human ear, it needs to produce 10 times the amount of energy. That's the logarithmic scale. But what we're looking at is going to be directly the intensity, not the sound level. So if your sound sensor is going to be measuring in decibels, you will need to convert that logarithmic decibel scale into a linear intensity scale. It is also possible to find sound sensors out there, or various apps, that measure sound intensity directly, and you won't need to do that conversion. Either of those will work as long as you know exactly which one you are using. The last thing that's going to be very important performing this lab outside of the lab space is the space that you are performing it in. As you can imagine, things like echoes or couches, sound baffles, corners of rooms can greatly change how the sound is bouncing around the space. In its most ideal form, you would have a sound source in the middle of an empty field and measure all your distances from that. Barring that, the next best thing would be a long, straight hallway where you are staying down the middle of the hallway. You're not walking past things like doors in the hallway. There aren't tapestries or couches or pillows around. And you can have a nice straight line between your sound sensor and your sound source. Before you get too concerned about all of that and thinking about where you can find a long enough hallway, most of the interesting parts of this are going to be happening in distances of less than 6 odd feet or 2 meters. So you really only need 2 or 3 meter spaces to get most of the interesting effects. If you are not seeing a significant change in sound intensity within 2 meters, your sound source is either far too loud or far too quiet. And so you're only getting background the whole time, or you're only getting ear-piercingly loud the whole time. If you see that kind of thing happening, try changing your source volume, and you should see a pretty significant change within that first 2 meters, 6 foot area. When you are fitting your data in Logger Pro, you probably have some experience from Logger Pro usage in the past of their provided fitting equations. In this case, we need completely new fitting equations, which you will do by defining a new equation. And that defined equation will allow you to set fitting parameters of your choosing in that fit.
Thank you for watching this video. Here's the fact for this week.
The first microwave oven was invented in England as a safer way to thaw frozen hamsters.